Hello students, and once again welcome. So this is our lecture number 2 on chemical reactions, the chapter that I have already started in science, and this is for the 7th grade students, okay, of IGCSE. So in the first lecture, I think I talked to you about this mind map, okay. In detail, I explained you what all different sections are there in this particular chapter, chemical reactions. So we are going to now start with the very first section of this chemical reactions chapter, and that section was 8.1 in your textbook, and I have in my notes given it a name as section A. Okay, exothermic reactions, right? So let us get started with this today's session. So in this session, we are going to start with this definition of this exothermic reaction and what is the meaning of, first of all, exothermic reaction, right? So these chemical reactions, any chemical reactions, taking place, okay, it can be either of two types, okay, broadly speaking. Some chemical reactions, they need heat energy for the reaction to be proceeding forward, okay. And in some chemical reactions, the heat energy is produced by the reaction itself, right? So there are basically two types of chemical reactions. Okay, there are various other types of chemical reactions also, but right now in your case for the 7th grade students, you have to just try to classify chemical reactions into two. One is where the heat energy is given out, and the other in which the heat energy is taken in. Okay, so these exothermic reactions are the kind of reactions in which the heat energy is taken in. Okay, now this heat energy is also known as thermal energy, right? So definition is over here. A chemical reaction in which heat is evolved or given out, okay, are called exothermic reactions. Okay, so heat is also called as thermal energy. That's very obvious, right? And let us take an example. Suppose you take a carbon and you make it combine with oxygen. A chemical reaction is going to take place and the product form will be carbon dioxide. So this is a chemical reaction in which one atom of carbon represented by one red circle, two atoms of oxygen represented by two green circles, right? They undergo chemical reaction, they combine together and they form a product called carbon dioxide. And this carbon dioxide can be represented by a red circle in the center and the green circle on either side of that red circle. Okay, so this red circle is nothing but the carbon atom, and these two green circles are nothing but two oxygen atoms. Basically, it is CO2. Okay, carbon dioxide is CO2. The formula is CO2. But in your 7th grade, you're not supposed to learn the formulas. Okay, you can just write the equations in word form. This is known as writing chemical equation in the word form. But here, can you see, after this chemical reaction, I have written plus delta H. Now, what is the meaning of this plus delta H? Plus means something which is given out from that reaction. Okay, and delta H means delta stands for the change. Okay, the change, and H stands for the heat energy. So normally delta H means the heat energy. Okay, so heat and plus means it is given out. If it is minus delta H means heat energy is absorbed. Okay, so remember that plus delta H means heat is given out and minus delta H means heat is taken in by the chemical reaction, right? So in this particular reaction, I have written plus delta H. Okay, that means the heat is given out. Now when the heat is given out, where that heat is going to go? It is going to go to the surrounding, and the temperature of the surrounding will increase, because when heat enters into surrounding, the temperature of the surrounding is definitely going to increase. So this is indicating that this particular chemical reaction is exothermic reaction, because the definition of exothermic reaction is the reaction in which heat is given out, and here you can clearly see that heat is given out to the surrounding. Many times along with the heat, light and sound energy is also given out. Okay, now you must be knowing that whenever heat energy is given out, it is expressed in the form of light or sound. Okay, so whenever you see somewhere that heat energy is being given out, it will be seen in the form of either light or sound or both. Okay. Now, burning is an exothermic reaction. Now, burning of any substance, okay, is also an exothermic reaction. Any fuel like charcoal, wood, coal, petrol, oil, natural gas, these are all different types of fuels. Some are solid, some are liquid, some are gaseous. Okay. So fuels can be found in nature in various forms, solid, liquid, and gases. Charcoal, wood, coal are all fuels in solid form. Petrol, oil are the fuel in liquid form. Natural gas is the fuel in gaseous form. So when these fuels, they are burnt, okay, when you ignite this fuel, what will happen? The chemical energy of the fuel will be getting converted into heat energy. It will be converted into heat energy in the form of light and sound. So whenever you burn any fuel, you will always get heat given out. Okay, you'll see that heat is given out. Is that clear? Let us see some more examples of burning. So let me take you to the next slide. Okay. Now here, burning of some other substances also are discussed. Now remember, burning essentially requires oxygen. Now burning is always something, a process which always requires oxygen. Now this is very simple to understand. Suppose by accident somebody catches fire, suppose during the Diwali season, okay, during the Diwali festival, a child, while, bursting those crackers, accidentally catches fire. Okay. So what is the best way of, protecting or, helping that child? Somebody will take a blanket, a thick blanket, okay, and cover that child with that blanket completely. Okay. Now, what happens in the process when the child who has caught fire is covered with a blanket? The oxygen from the air is now not reaching that fire, okay, because the blanket has come in between that fire and the oxygen in the air. So, in short, what you are doing is you are cutting off the connection of oxygen. Okay. So now, when the oxygen is not there, the burning will not proceed. Okay, so this is how burning can be stopped. Burning can be prevented by just disconnecting the oxygen being added to it, right? So the reverse of this is, for any burning process, oxygen is very, very essential. Without oxygen, burning cannot take place. Now let us understand this chemical reaction in which hydrogen, which is a gas, when it is combining with oxygen while burning, of course, when it is combining with oxygen, this is known as a chemical reaction where hydrogen and oxygen are combining together and we are burning the hydrogen. Okay, and that is how oxygen and hydrogen are combining in that process. What will be the product form? It will be water. So this is a chemical reaction, but this is an exothermic chemical reaction. Why? Because heat energy is evolved. Heat energy is given out. See, plus delta H means heat energy is given out. Okay, so in any burning process, heat energy is given out. And it will be given out also in the form of sound and light, right? So how you have to represent this chemical reaction for the 7th grade? You will take 4 black circles indicating the 4 hydrogen atoms. You will draw 2 red circles representing 2 oxygen atoms. They are combining together, so you'll write a plus in between them. Arrow mark is indicating that now the product is going to be formed. The product formed will be water. And how you have to represent water? You will represent by these 2 red circles, which are nothing but oxygen atoms, and these 4 black circles, which are representing 4 hydrogen atoms. Okay, all will be sticking to each other. So this is one particular product or one compound form, water, right? Now here you have to take care of one thing. You have to see that the circles, particular type of circle on the left hand side as well as on the right hand side of the chemical reaction, that is separating this aroma. So every circle of a particular type, like say black circles, on the left hand side of the arrow and on the right hand side of the arrow should be equal in number. Same with this red circles. Red circle should also be same in number on the left hand side and the right hand side of this arrow. This is known as something called balancing a chemical reaction. So a chemical reaction is always balanced. It has to be balanced. Okay. So don't make the mistake of imbalancing it. Okay. If you do some mistake, if you show something, suppose here there are 4 hydrogen atoms shown on the left hand side. By mistake, suppose here you show 6 hydrogen atoms or maybe 3 hydrogen atom by mistake, that will be something wrong, right? So this is a chemical reaction in the word form that you are writing. Okay, plus delta H is heat energy is evolved, which will of course go to the surrounding. Second example of burning is you can think of burning magnesium metal. Okay, you can ignite or you can burn magnesium metal in presence of air, and air will always have oxygen. Okay, in air the maximum oxygen you will find in the air, maximum oxygen you will find hydrogen, nitrogen, but those are in very small quantity. Okay, so when you are burning something in air, you can always think of oxygen being consumed from the air in that burning. Okay, so magnesium I am representing now by 2 green circles. So there are 2 atoms of magnesium represented by 2 green circles, 2 atoms of oxygen represented by 2 red circles. They undergo chemical reaction on burning, and the product form is magnesium oxide, and it will be shown in this way: 2 green circles attached to these 2 red circles. Okay, and you will have heat energy evolved. Okay, so there will be heat energy evolved. So plus delta H I have written. Okay, this is how you have to show the chemical reaction in the word form. The third one is potassium reacting with water. So potassium I am showing 2 red circles, 2 atoms of potassium. Water I am showing in this way. These are 2 green circles which are representing oxygen atom, and these 4 black circles are representing 4 hydrogen atoms. So water formation requires 2 oxygen atom and 4 hydrogen atom. So this is what I have shown here. Now this, when they combine together, a chemical reaction will take place, and the product form in this case will be 2 products. One will be potassium hydroxide and the other will be hydrogen gas. One will be potassium hydroxide and other will be hydrogen gas. Okay. So can you see this potassium hydroxide I have shown here, and here hydrogen gas, 2 atoms of hydrogen. This is also an exothermic process, so heat energy is again given out in the surrounding, to the surrounding. So this is also an example of exothermic reaction. Okay, that's all for today's session. In the next lecture, lecture number 3, we'll proceed with the next section of this chapter, chemical reactions. Bye.